Good morning. So today what we're going to do is we're working on the next section, which is transforming parabolas and quadratic equations. So in your pre-algebra class, you guys would have covered transformations, and transformations would have been things like reflections, dilations, rotations, and translations. So you guys did those with shapes or points last year. We're going to do it with the quadratic function or parabolas in this particular section. Okay, so we're going to start off with our reflection over the x-axis. So just to cover something that we did in a couple videos ago. So if we have y is equal to ax squared, we know that if a is positive, the parabola is going to point up, so it's going to be happy. It's positive, so it's happy. If it's negative, the parabola points down. So it's negative, it has an unhappy face, right? So the parabola points down. So we know that the shape or how the parabola opens is all based on that a in front of the x squared term, okay? So if we take our basic quadratic, just f of x equal to x squared, right? So this is where, if I'm at 0, my f of x or my y is 0. If I'm at 1, 1 squared is 1, so I have 1 comma 1 is another point. If I have 2 for my x, my y is 4. If I have 3 for my x, my y is 9. So this is where our perfect squares come in. Same thing with our negatives. We square negative 1 becomes a positive 1. We square negative 2 becomes a positive 4, and so on and so on. So we've got our f of x equal to x squared, right? So if we want to do a reflection of x squared over the x-axis, what would that look like? What would our function look like? So our graph, we can pretty much go, okay, our graph is going to look like this, right? I gave away the answer there, but still the graph is going to look like the unhappy face. It's going to be pointing down. So with that, our formula is just going to be taking our term and multiplying it by a negative 1. All right. So if it's negative 1, it's multiplied by negative 1, we get a negative x squared. Okay. So I'm just running a little low on my battery. That's what I was just checking. All of a sudden, I get a message. So that's for that one. We multiply it by a negative in order to do a reflection over the x-axis. So reflection, multiply each term by a negative 1. So in this case, we've got two terms. We've got f of x is equal to x squared plus 3. So we want to multiply each term by negative 1. So if we multiply x squared by negative 1, we get a negative x squared. And if we multiply positive 3 by negative 1, we get a negative 3. So our function should be negative x squared minus 3. And remember, our initial function is just like with our vertex form, right? That k, when we have like an x squared term here, this is basically in that same form, but it's basically just, we have nothing for a. We have a 1 for a, and then it's x minus 0 squared plus 3. Because our vertex, remember, it's 0, 3. The h and the k represent what our vertex is. So 0 on our x, 3 on our y, so 0, 3. That's our vertex. So that's what our initial equation was. In order to do a reflection of that, we multiply each term by the negative. Okay. So let's try. So that's reflection. So now let's move down to doing a translation. So now we're going to start shifting the parabola up or down. So again, if we look at this right here, right, our vertex is h comma k. So our x is, h represents our x coordinate, right? All right. And our k represents our, should have done this. Let's see. Our k represents our y coordinate. So k represents the y coordinate, x represents, or h represents the x coordinate. So if we're going to go up or down, what do you think we're going to change? Which one, the h or the k? All right, so if you said k, right, k is the y coordinate. So that's going to tell us whether or not we're going to go up and down. So if I want to go, if I want to shift this up by 3, what do I need to add to this equation? And so if I was to do that, let's take a look. So if I add 3, because I want to go up, I add 3 to this equation. This is what our graph is going to look like, right? So the green represents where I did a translation up by 3, or I shifted it up by 3. And if we look, we're at 0, 0, 0, 1, 0, 2, 0, 3. So there's our vertex, 0, 3. If I wanted to shift down by 3 from x squared, right? So I'm taking f of x, so the x squared, I'm going to shift it down by 3. What do you think my equation would be? All right, so if you said it would be x squared minus 3, you're right. So now we're at 0, 0. We want to shift that down by 3. We go down on our y-axis by 3. So we're changing that k value. That's all we need to change in order to go up and down, okay? So let's try one more. That's a little bit more to it, right? So if f of x is equal to x squared plus 3, what is the equation when f of x is shifted up by 4? So I want you guys to try that. All right. So if you said, and I just did a new function notation for it, g of x is equal to x squared plus 7. So on this one, all I did was I added 3 plus 4, I get 7, right? So I started off at 3, I went 1, 2, 3, 4, I'm up on 7. If I want to take f of x squared plus 3, and I want to shift it down by 4, what do you think I'll get? All right, so if you said negative 1, x squared minus 1, that'd be correct, because we're going to start from x squared plus 3, and then we're going down 4 units on the y-axis. 1, 2, 3, 4, and we end up at, our vertex ends up at 0, negative 1, okay? So again, we want to remember this vertex form really helps us out, especially with these transformations. So that covers reflections, that covers translating up or down. So now we're going to go with the translation going left or right. All right, so let me just move this down just a little bit. Okay, so on this one, can't get it exactly right. So when we do a translation left or right, again, what do you think we're going to use, h or k, to translate it left or right? Okay, so if you said h, which represents our x coordinate, you're correct. So the tricky thing with this is, remember that it's a positive h here, but when it goes into this equation, it's x minus the positive x coordinate. If this was a negative number, that makes it x plus whatever that number is, okay? And we covered that before, but we'll cover it a little bit again just when we get into this. So again, we're going to start off with our basic function, f of x is equal to x squared. So if we want to shift it to the left by 3, so I want to take this and I want to go 3 spots over here. So if my vertex currently is at 0, 0, where do I want my vertex to end up if I want to shift it to the left by 3? I'm going to go 1, 2, 3. So I want my vertex to end up at negative 3, 0, right? Which means that, again, that's my h, and that's my k. So if I put this in, I get x minus a negative 3, which makes it x plus 3. Remember, keep change when we have when we're subtracting a negative. So when I do that, what do you think we'll get for our equation? All right, so we're going to go from x squared, right? We're going from this x squared, we're shifting it left, so we go x plus 3, which is squared, or you can think about it as this original equation could have been written as, if I put it in vertex form, it would have been x minus 0 squared, Okay, so if I had taken x minus 0 and I wanted to shift it to the left, so I want to go negative, I would have said, okay, let me take 0, which I had up here, and I want to subtract 3 from it. And then this would have given me x minus, wow, negative 3, right? And all that squared. Okay, so x minus a negative 3 or x plus 3 squared. Okay, so that's how you would have gotten to the one right above it. So this one right here. So if we translate or shift to the left, we're going to get a, we do that math on it, but this would give us a positive because we're going to the left of the y-axis. So if we want to shift this x squared function, if we want to shift it to the right by 3, what do you think we're going to get for that? All right, so when we shift to the right, and again, this is, this one right here, the x squared is the original. We're shifting to the right, so we're going to go 1, 2, 3. So our vertex is going to end up at 3, 0, right? And if we just plug that right in, we have a 1 for our a, x minus 3 squared plus 0, okay? So we would have ended up with x minus 3 squared plus 0. Another way is, I have that 0 in there like I had written up here. The 0 plus 3 gives me a positive 3, so it's x minus 3 squared. All right, so let's do the next problem. I want you guys to stop and do it on Edpuzzle. All right, so if f of x is equal to x minus 3 squared, what is the equation when f of x is shifted left by 4? So I want you to try that one, answer that question. All right, so on this one, if we're going to shift to the left by 4, we're taking x minus 3. So this is the original equation, right? I got it represented here. F of x, x minus 3. Here's my original equation. My vertex is 3, a positive 3, 0. And I want to shift it 4 spots. 1, 2, 3, 4. So it's going to be at negative 1, 0. So I could write it as, okay, I know that my vertex is going to be negative 1, so it would be x minus negative 1, which would be x plus 1. Or I could have said, okay, let me start off with my original equation, and I subtract 4 from it. So 3 minus 4 would give me a negative 1. So I end up with x minus a negative 1, which again, change would give me x plus 1 in the inside. Okay, so that's how I get to my equation when we're shifting to the left. We're going to subtract, and when we're shifting to the right, we're going to add. So now I want you to try this one. So we're taking this original equation again, f of x is equal to x minus 3 squared, and we're going to shift right by 4. So I want you to write down what you think the equation would be, or do it on Edpuzzle. All right, so again, here's the purple is my original equation. It's right there. F of x is equal to x minus 3 squared. I'm going to shift 4 spots, 1, 2, 3, 4. I end up right here. And so I know that I'm going to have 7. My vertex is going to be 7, 0. And if we knew that and just plugged it right into our vertex form, I would have gotten this. But if we want to just do the math, do the translation, we would have, we could have taken 3 plus 4 would give me 7, so it's x minus 7. Okay. When you're doing these problems, mistake this. So x minus 3 squared. So Desmos is a great tool, right? So I've got so with x minus 3 squared, right? So that's what we had. So if I was to take a look at this and go, okay, let me see. If I went 4, right? If you want to try this out, you can go, okay, I'm only a difference of 1. But you could more or less try it out in here and see, okay, I got x minus 7. That minus sign is a tricky part. It would make you think that you're going to the left, but you actually go to the right in this case because that's your standard form is a subtraction sign inside there. So if you use Desmos, it's a quick and easy way just to double check your answers and try it out. So let me do one more problem for you guys. What if I had, all right, what if I had x minus 6 squared? Right, I'm just going to get rid of these guys. So x minus 6 squared, if I want to shift to the right by 6, okay, I'm going to shift to the right by 6. What's my equation going to be? So y is equal to what? All right, so try that one, and then we'll move on to something else.